Well, first I'm going to explain how are new materials made. Most new materials are developed from existing materials. Scientists try out new combinations of elements. They apply heat and pressure to materials to impart new properties. Well, our three new materials are plastic baroque. The island in the island of plastic in our Pacific Ocean is really confirmation that we need to better engage with our consumption of plastics. A graduate of the RCA's Design Products program, James Shaw has created a handheld gun that converts thermoplastics into playful, extravagant furniture. The plastic extrusion gun features, alongside an arsenal of their weapons that made up Shaw's graduation show, including a beer match and the powder gun. The plastic extrusion guns turns the extrusion of polymers, usually an industrial task carried out in distant factories, into a handheld process. Using this process, the designer has launched his Plastic Baroque range.
The principal application of plastic baroque is the custom furniture creation and aesthetics of organic materials.
Advantages of plastic. Advantages of plastic are light and weight. They can be easily molded and have excellent finishing. They possess very good strength and toughness. They possess good shock absorption capacity. Advantages of plastic are corrosion resistant and chemically insert. They have low thermal dissipation of coefficient and possess both thermal and electrical insulation properly. Advantages of plastic is very good wear resistant and possess good adhesiveness. And plastic is strong, good and cheap to produce. Disadvantages of plastic. Plastic is a non-renewable resource. Plastic is softness, cause cancer. Disadvantages of plastics are embrittlement at low temperature. Disadvantages of plastic are deformation of the lobe, are low heat resistant and poor ductility, and plastic are combustibility.
Then, unbreak glass, developed by research at Tokyo Institute of Industrial Science in Japan. This fresh form of glass is nearly as strong as steel, with potential application ranging from the electronics to vehicles and architecture. On scales measuring strength, this new material ranked on par with metals normally used for industrial application. The scientists published their findings in Nature and aim to commercialize their work in the next 5 years, bringing into tables, computers, smartphones, cars, buildings. It is still thin like a see-through-like type glass, used far more robust. Alumina is the critical ingredient. Mixed with silicon dioxide, this strengthening agent had to be added in a new way to keep it from crystalline before the glass could form.
The applications of the unbreakable glass are for protection of tablets, computers, smartphones, cars, and buildings.
Strong as steel, sensitive, unbelievable new unbreakable glass. Aluminum is the critical ingredient mixed with silicon dioxide. This strengthening agent had to be added in the new way to keep it from crystallizing before the glass could form. And aluminum synthetically produces aluminum oxide 8L2O3, a white or narrowly colorless crystalline substance that is used as starting material for the smelting of aluminum metal. Silicon dioxide is a trace mineral found naturally in many plants' food and is added to many multivitamin supplements. It is necessary for healthy bones, skin, hair, and nails. Silicon dioxide is often added. Disadvantages: optical distortion. The lesser the distortion, the better will be quality. Roller marking. It is produced if the glass is poorly handled in the furnace chamber. Well, weakness and bending. It is easy and defect-freely paint and characteristic of heat-treated glass. Edge strength. The stronger the edge, the less likely will be the thermal breakage. Advantages: strength is 4 to 5 times stronger than the annealed glass. Safety is the disintegrate into a relative smaller piece when broken by pressure, reducing serious injuries and accidents. Edge strength: it is highly strong from the edge as compared to normal ordinary glasses. Thermal breakage: it is highly resistant to withstand any of thermal breakage.
Well, then, biologic shape shifting fabric sense suite and transforms. The development by MIT's Tangle Media Group, this remarkable clothing used to microorganisms to sense perspiration and heat, changing shape to let your body breathe on demand. As a bonus, the material employed are fooled by breaking down properties your body exhales while sweating. Bacillus subtilis nano bacteria react to atmospheric moisture, expanding and contracting in response to humidity and heat. A specially primed biofilm is overlaid on expanded suite as shown in the video above. The special cells sense change on the body, curling up and thus allowed more airflow when things heat. MTA is now printing billions of these and test in various applications. In the era where biology is the interface, we are imagining a world where actors and sensors can be growth rather than the manufacturer.
Okay, biological shape-shifting fabric senses suite and transform. Bacillus bacteria reach to the atmospheric moisture, expanding and contracting in response to humidity and heat. The most elegant technique involves electroporation of the so-called transposon complex into cells. We describe the construction of integrated elements with TC-sensitive outward promoters and their use for manogenesis of B subtilis. We have obtained a number of conditional growth deficient or autotrophic B subtilis strain using this construction.
The applications of the shape-shifting fabric senses suite and transform. That's principally of this remarkable clothing uses microorganisms to sense perspiration and heat, changing shape to let your body breathe on demand. As a bonus, the bacteria employed are fueled by breaking down proteins your body expels while sweating.
Advantages are single membrane, ability to of potential parts, natural competency and integration, and exploration transport. And these disadvantages are peptide activity, sublease parts, vector degradation, and spolarization.